In this lesson, we're going to talk about structures. And like enumerations were called enums, you will hear me reference structures as structs. When we talked about classes, we talked about two parts of classes. Things that describe what the object is and things that the object does. Structures are very similar to classes, but the purpose of them is simply to represent descriptions or items of an object. It is not to perform actions, but rather to represent a data structure. So for instance, when we talked about a dog can have a description like a breed, a height, or a weight, and it can do things like run and bark and jump. A structure is a bit different, where we're not describing the things that the structure can do, just things that describe the structure or properties that the structure has. So for instance, if we wanted to decide whether or not to use a class or a structure for dog, because it can both do things and have properties, we would choose to use a class. If we were looking at something like an assignment for a class, in this case, a course, in and of itself doesn't do anything. It has descriptors like name of the assignment, description of the assignment, possible points. But the assignment in and of itself doesn't really do anything. The assignment doesn't take a test. The assignment doesn't give an answer. It has things, but it doesn't do things. So that's the big difference between a class and a struct. You're not going to use structs this early in your programming career, but in your next course, especially as you talk about data structures and algorithms, searching and sorting, structs are going to be very important because, again, they represent a type with multiple description attributes. So let's build a struct. We mentioned assignment. Let's build a struct that represents an assignment. I will type some things out and then explain them. So as you can see, as I did with classes, I broke this down into three sections: fields, properties, and constructors. You'll notice the difference between here and a class is I'm not implementing methods. The point, again, of a structure or a struct is to create a data structure, not to create an object that does things. So in this case, all we're doing is storing data. Now, in a structure, you can have a constructor, and there are caveats to that, because you want to initialize values on the structure. However, again, the structure in and of itself doesn't do things. So here we have an assignment, and maybe in this assignment we have a name. So this will be a field, so private string name, private string description, and we'll do a private int points. So that'll represent maybe possible points of an assignment. It'll be up to 100. And just like in a class, you have properties. So public string name encapsulates the name field. So here we have a getter, return name, and a setter. Name equals value. And we have the same properties for description and points. So just like if I was building a class, an assignment here, again, we have fields and properties. All of these describe the struct. And just like in a class, you can have a constructor. However, the caveat is you cannot use a default constructor. You must create constructors that are parameterized. Again, the point of the structure is to have data in a structured manner, and this limitation forces you as a programmer to set the values on your structure. So for instance, if I did public assignment and try to create a default constructor here, you will get an error that says structs cannot contain explicit parameterless constructors, meaning you must have constructors with parameters. The second part of that is if you add a parameterized or constructor or constructor with parameters, you must use those parameters and assign them to your fields. So here, if I create a constructor with string input name, string input description, and int input points, you'll receive another error. Assignment.name, assignment.description, and assignment.points all must be fully assigned before control is returned to the caller. Meaning if you're going to have a constructor, you must assign default values to all the fields. So here I must set name to the parameter input name, description to input description, and points to input points. Again, this isn't like a class, so you cannot have a default constructor. You can also, if you notice here on line 13, not have any field initializers. So you cannot say, sorry, I did a string, but name equals my assignment. You are not permitted to do that. You must initialize all fields through a parameterized constructor if you're planning on having a constructor in the first place. Otherwise, if you don't have a constructor, if we comment this out, all values in a struct, when an instance of a struct is created, are set to their default values. So a string is set to an empty string, an integer is set to 0. So let's go ahead and use our struct for the first time. So here we called our struct assignment. So in our main method, we're going to create a variable of type assignment, assignment week 7 test equals new assignment. Now, there's two ways we can do this. The default constructor, even though we couldn't create one ourselves, C# automatically creates it, is still there. So we can use the new keyword and assignment and then assign values to the properties ourselves. So week 7 test dot name equals week 7 test, week 7 test dot description equals test on structs, enums, and more. And week 7 test dot points equals, I think your tests are 20 points, so 20. And there we go. It's just like using a class. It's just like using properties on classes. And just like we created parameterized constructors in classes, we can use our parameterized constructors in structs as well. So here we had, if we look at assignment and we look at our IntelliSense, our second option is to put the name, the description, and the points in our constructor. So here, name, description, and points, and we've done the exact same thing. So again, not much use to you now, but as you get into data structures, you're going to want to use structs to declare sets of data that have different properties that do not have actions associated with them. If you start getting into C++, you'll learn the true reasoning for this is there's a lot less memory overhead to create structures versus classes, especially when you're doing large trees of data structures, searching and sorting. It's a lot cheaper in both the number of operations and in terms of memory usage to not declare a full class, but rather create a struct instead. So in the future, you'll have to make decisions. Should I build something as a class or should I build it as a struct? But at least for now, you have an idea of what a struct is, how to formulate it in code, and how to use it. And again, the format is very similar to a class. You have your fields and properties and constructors. You do not have methods, and also remember that your constructors must be parameterized. You cannot use a default constructor on your own. Also remember, you cannot set fields to default values. You must do that either through a parameterized constructor or after you create an instance of the struct, you can assign values to properties, thus assigning values to fields.